Let's talk about how to implement a finite state machine in code the nice and easy way using enums as our states. So to start, I have a script here called click to move. It's relatively straightforward. It has reference to a main character, a boolean on whether or not it's currently moving, and a path that it's going to follow. In the update function, there's essentially two main components to it. One that's checking if it's not moving, and then it gets the left mouse button. It determines where a point has been clicked and generates a path. And then the important thing is moving becomes true if this happens, to indicate that our character should start moving along the path that it's generating. Then there's another section here, which is if it is currently moving, and it checks if what the target is, which is based on which element in this path it should be currently moving to, and does the appropriate moving logic. So there's sort of two different phases or two different states that this AI can be in at any given time. One is whether it's not moving and it's sort of looking for this left mouse button click to determine if it should move. And then the other is if it is currently moving. There's also one other little tiny piece of logic down here that checks if we are not moving, and it makes it so that it stops the main character's motion. So to convert this, and now many of you probably have a lot of scripts like this where you have an update function and then you have a whole bunch of different sort of like, clumps of logic inside of it, inside these if statements, where you're like, if this bool is true, then do this set of logic. If this bool is true, then do this set of logic. And whenever you kind of see this thing, it's the perfect opportunity to convert your code into a state machine, which, as you'll see, will make our code a little bit nicer and easier to read. So to start, I'm going to define a brand new enum up here, and I'm just going to call it AI state. And we talked about there's two states right now that this code is using. There's either moving and there's not moving. I'll just call it idle. And the AI right now is in one of those two states, either moving or idle, right? And there's a couple different things that can cause us to transition between those states, right? This is just like with the finite state diagrams that we looked at previously, where you have these nodes as our states and then you have various transitions between them. Now, the next thing we need is we need this AI to hold on to an instance of this enum to determine what state it's currently in. So we can just say AI state current state. And we're going to initialize this to idle, right? Now, our update function is doing these two big blocks of essentially if I'm idle, and then another one that's like if I'm currently moving. So we're going to write a brand new update function, which is going to replace the current one. Not fixed update, a brand new update function, which is going to replace the current one. And in this update function, we're just going to operate based on what state we're in. So if we're in the if our current state is idle, we do the idle logic. If it's moving, we do the moving logic, right? And now the really nice way that this breaks up our code is something like this. We can say we want to switch based on what our current state is. And then we can say if our current state is idle, then we're going to write a brand new function that's called like do idle. And then if our AI state is moving, we're going to write a brand new function that's called do moving. And now some of you may already be able to see how this is going to be, how this is going to kind of simplify this. So let's create a brand new function called do idle, and this is going to be all of the logic when the AI is idle. We're going to do another one called do moving, and now this is going to contain all of the logic for when the AI is moving. And now really easily, what do we want this thing to do when it is idle? Well, this is what we want it to do when it's idle. It's this section of our old update code. I'm just going to move this right into our do idle. We don't need to check if it's not moving anymore. We just say, check the left mouse button, generate a path for us. Oh, also, by the way, we need to do this logic here, which says that we shouldn't be moving anymore. Those are all of the, that's all the logic that should be happening if we are not currently moving. Now, if we are moving, what logic do we want to do? It's this block of code right here. So we can just grab this block of code and throw it right here into this do moving function. Now this update function, I've completely removed everything from it. And so we have these nice clean functions of this is what I do when I'm idle, this is what I do when I'm moving, and these functions are called right here from our one update, which is kind of driving our finite state machine, so that every single update, it does one of these two pieces of logic, do idle and do moving. Now, the last part of this is previously we were using this bool of with, whether or not we're moving or not. Well, we're not going to use this bool anymore because now this is all based on what current state we're in. So down here, when we say moving is equal to true, instead of saying now we are moving, we would say our current state is equal to AI state dot moving. And then down here, when we would otherwise set moving equal to false, we'd say our current state is equal to AI state dot idle. This is a really nice and simple way to mimic exactly how a finite state machine operates in code. We've got our states, we've got our one update function that does one of those sets of logic either for idle or for moving, and then we have each one of our states set up as their own independent function.